So we saw how a dendrogram is being created. So agglomerative testing or agglomerative clustering is basically, there are few steps in it, and the step one is so step one is let all the points belong to one cluster. So it considers that all points belongs to one cluster. That's the initial it considers. Step two, it identifies the proximity distances or the Euclidean distances. Okay. So step two is it identifies the proximity distance or Euclidean distance by summation of I is equal to 1 to the total number of points xi minus of yi the whole square for all I belongs to 1, 2, 3, so on up to n. So step 2. Then I perform step 3 such that merge 2 points into one cluster. I'm going to merge 2 points into one cluster which has minimum distance, that is based on its similarity, because we all are working on similarity itself. Only the similar data points is grouped. So it initially starts with all random points. It initially considers all the points that I have, it belongs to one single cluster. Then I start identifying the distances between the cluster, and in that first I'll identify which are the 2 points that are close to each other. You can see here, is there any points that are close to each other? So I can see that there are something that these points are actually close to each other. I can again tell probably these 2 points are close to each other. Okay. So identify the points which are close to each other and merge them into one cluster based on its similarities. And I would be doing that. And step 4, repeat the process until the points in the data set is exhausted. So I have to repeat the same step. What will I be performing? I will consider the distances between the two and I'll check out which is having the lowest distances. I will group them into a cluster. That is what I'll be doing this repeatedly. So repeat this process until all its points in the data set is exhausted. So the main important steps, very, very important, agglomerative clustering. As I told, agglomerative clustering, it is basically on a procedure where it identifies the similarities between points. But I mean, when you look at agglomerative testing, when you look at the outer picture, the one that I showed you, that A and B, C and D, okay, there was A, B, which was close to each other. There was C and D, which was close to each other. And there was E that was close to C and D. And finally, we have this entire cluster. We saw how the dendrogram was created, right? So basically, how do we perform that is, we identify the distances between the two, and the shortest distance is what we put it into the cluster. So I'll be performing that, and I'll repeat all the steps until all the points in the data set is exhausted. Okay. So each and every data point when I take, I will identify the distances between that, and from the distances I will start grouping it. We'll look at one of the examples to go more in depth about, okay, why agglomerative testing is, I mean, clustering is really important, or why do we actually need to go ahead with this hierarchical clustering. Okay. So we'll look at the we look at the problem statement directly, because that will really help us to understand what exactly is agglomerative testing. Okay, so the question is like, apply agglomerative hierarchical clustering algorithm for the following data set. I have the points. I want you to note down the data set so that we will be solving this problem together for a very good understanding. So I have the X and Y. So point P1, P2, P3, P4, P5 and P6. So I have 6 points in my data set. What is step 1 indicate? What does step 1 indicate?
Let all the points belong to one cluster.
Exactly. So we'll consider all of these things will fall under one cluster, and the value of the X and Y points is 0.40, 0.53, 0.22, 0.38, 0.35, 0.32, 0.26, 0.19, 0.08, 0.41, 0.45 and 0.30. So this is the data set that I have right now. Okay. So agglomerative testing, step 1 is, let us consider all of these points belongs to one cluster. I'll just write in a small here. Okay. This is the diagram and I have 6 clusters, 1, 2, 3, 4, 5 and 6. Okay. I'll consider all of these data points, okay, to form one cluster. But now I have to create that hierarchy, like, okay, what are the similar data points in it? I have to first close them. Again, similarities within the other, and I put everything under one cluster. So the second step would be is identifying the Euclidean distance. So I have to identify the Euclidean distance. How do I do? From point P1 to P2, what is the Euclidean distance? From point P1 to P3, what is the Euclidean distance? So I'll be identifying these Euclidean distance one after the other. I'll take one point after the other point. So I'll create one more table over here to identify that Euclidean distance. So please note down that I want you to calculate and let me know the Euclidean distance values. Okay, so I'll have point P1, P2, P3, P4, P5 and P6. And again I have P1, P2, P3, P4, P5 and P6. So since I have 6 points, I'll start initially with the first point. And I have to get to know the distances between that, right? So I'll write the distance formula over here, the Euclidean distance, x comma y with a comma b is basically square root of, we already know the Euclidean distance formula, x minus of a the whole square plus x minus or y minus b the whole square, okay. So we already know the distance, x minus a the whole square plus y minus b the whole square. Now I've got the first point. What is the distance from P1 to P1? I'll take, this is my chart,
0.
right? I'll take the first point in it. What is the distance from P1 to P1?
0.
Because the distance, there's nothing that I have to calculate. It comes to the same point. So the value of that is 0. So all of the values, the diagonal values is going to be 0. Okay. And from P1 anyways, okay, I have not got it. So then I'll take second point. I'll start working on with the second point. Now I've fixed, one point is already ready. So I'll fix the first point. The first point P1 is already done. Now I'm going ahead with P2. I'll start with second point P2. Now I have to identify the distance of this P2 with respect to P1. So first P1 is done. Now from P2 with respect to P1, I have to identify the distance. So what will be from P2 to P1? Can you please calculate it and tell me? What will be the distances from P2 to P1? Substitute the equations, the distance is the values of it in the equations, and let me know. Anyone, did you get to know the answer?
Point 234.
Exactly, yes. So I'm going to write it over here, 0.23. Okay, so I'm done. And P2 to P2 is nothing. I'll get no value for that, that's fine. Okay, 0. Then what I do, I will identify from P3 to P2 because I've got a new candidate. Okay, so I've got a new candidate P3, the data point. From P3 to P2, I have to get the distance. What will I get? So 0.35 minus of 0.022, the whole square, plus 0.32 minus 0.38, the whole square. What will I get the value from P3 to P2?
Point 143.
Okay, 0.143 from P3 to P2. Now again I have to calculate because there are 2 points before there, right? So I have to calculate again from P3 to P1. So which is 0.35 minus of 0.40 the whole square plus 0.32 minus 0.53 the whole square.
Point 2.
Point
21.
Excuse me, I'm sorry. Okay, 0.21. Fine. So I got the distances between that. And then came up another P4 candidate, a student telling that, oh, hey, even I'm in the group, man, come on, now start identifying me also. So P4, a USN number comes into picture. So now what we'll do is, okay, let's identify that person with respect to P3. What will be the value? P4 with respect to P3. It's 0.026 minus 0.35 the whole square plus 0.19 minus 0.32 the whole square. P4 to P3. Yes, any value? P4 to P3?
0.15.
Okay, 0.15, correct. Okay, now again from P4 to P2 and P4 to P1. What is the distances between those points?
Ma'am, P4 to P1, 0.36. Wrong, ma'am.
So did you get to know, guys?
Ma'am, P4 to P1,
Yeah,
0.36.
okay, 0.36. How about P4 to P2?
0.149.
0.14. I've got
1949.
0.2. 194. Okay, yeah. 0.2. 194. I'm just writing it as 0.2. So now next, I have to go ahead calculating from P5. I have a new item, new person again coming into picture, and he tells, come on man, now I've joined the new group. So even try to, I want to interact with each and everyone. So the person will start interacting first with P4, again with P3, P2 and P1. So can you get me the distances of from P5 to P4, P5 to P3, P5 to P2 and P5 to P1?
And 0.284.
284 for P5 to P4?
P5 to, yes ma'am.
Okay, so I'll write it as 2.8.
Same for P3.
Next.
0.14.
True, correct.
0.34.
Yes.
0.4.
Nice. Okay. Now again, one more person comes in to picture and he tells, yes, even I am over here. Can you please identify P5 to P6, P6 to P5 distance, P5 to P4, P4 to P3, P2, and finally with P1. So from P6 to P5, is it 0.39 that you have got?
Yes, ma'am. Then 0.219.
So, okay, 0.39. Is it right?
Yes, ma'am.
0.21
Yes, ma'am.
or 0.22? And what is,
219, so 22,
yeah,
I think.
22. Okay. So then from P6 to P3?
Zero point 101.
0.110 or 0.11?
101 I got.
Okay, okay, I'll take it as 10 itself. Okay, next. P6 to P2.
0.243.
Oh, very nice.
0.24.
Okay. P6 to P1.
0.23.
Yes. Cool. So we are in the first step of it, identifying the distances between the data points. Now we saw as and how each and entry is coming, we are identifying its distance with all the other points. Okay, and we got this particular table. From here, we have to identify the data points that has the shortest distance, because that is our third step that we do, right, in the algorithm. The third step is identify the shortest distance between the two data points and form it one cluster. What is the data point that has, which are the data points that has very less distances between them?
P3, P1. Okay. No.
Which has a very less distance.
P6, P3, ma'am.
Exactly. So from P6 and P3, this is the distance that has the lowest amongst the other distances that we have calculated. I will start constructing my dendrogram. I will start constructing my dendrogram. How do I construct? Because these two distances are like this. So I will write it. The data point number 3 and data point number 6 forms one cluster. I will represent it like this. 3 and 6 will form one cluster. So that cluster is ready now. Now what I do next is I will identify the distances from these 2 points and recalculate the distance matrix. So my next step will be, please have a keen note. I want you to be very keen at this point. We have already identified the distances between, the lowest distance between 2 points, which is P3 and P6. Okay. Now I'm going to identify from these two. Okay. From these 2 points, we already know that. From here, is there any other point which is close by? You got why we are identifying it? Because when I told A and B, okay, I have A and B points, so I made them into group. I'm just trying to identify, is there any point that is closer to this so that I will form another cluster. Getting this point? I already got to know the distances between P3 and P6. Now I am going to identify, is there any point, any data point that is close to this cluster? This is already clustered now. Since the point is very low, the distances is very low, I've already formed a cluster. But with respect to this cluster, is there any data point which is closer to it? So recalculate the distances. So I'm going to recalculate the distances from here. I'm going to start from here now. From here to this particular point, what will be the distance? I will again recalculate this table. Okay. So to do that, what I'll do here is I will just erase the left hand side of it. For now, I'm not going to use this. Okay, so now what I have to do is I have to recalculate it, right? Recalculate from what? Rather than having
96.
sorry,
No, nothing.
so I will be recalculating the distance from P3 to P5. So what I'll do, I'll write identify the minimum distance from P3 to P6 with the first point P1. But I already know if I have to take the minimum distance from P3, P6 and P1, I can take the minimum distance of this and minimum distance of this, right? So I will write from P3 to P1 the distance, comma, from P6 to P1 distance. What is the distance from P3 to P1? From
0.21.
From P3 to P1, 0.21. So 0.21, comma, what is the distance from P6 to P1?
0.23.
Yes. If I have to take the minimum distance, what will be the minimum distance now? 0.21. Right? Then what I'll do? I've got for the first point. I will calculate now for the second point. Identify the minimum distance from P3 to P6 with the point P2. So it will be P3 to P2 and P2, P6, P6 to P2. So P3 is here, P2 is 1.43. So it's 0.143, comma, from P6 to P2, P6 to P2 is 0.24, 0.24. The minimum distance of it is 0.143. I'll take the third value. Third value is minimum distance of P3, comma P6 with, I can't take P3 again because P3 is there already. So I'll take P4. Okay, so from here to here, I have to identify the distance. P3 to P4, P3 to P4 is 0.15, 0.15, comma, P6 to P4, P6 to P4 is 0.22. So obviously I'll get 0.15 is the distance. And the last point I have is from identifying the minimum distance from P3 to P6 with P5. So from P3 to P5 is 0.28, 0.28, comma, P5 to, now P6 to P5, P6 to P5 is 0.39, so 0.28 is the smallest. So I've got all the four values now. I will update this matrix now. Whatever this matrix, I've got it, right? I will update this new matrix because I've already got the distances, a new cluster I can form by looking at the distances. So I'll again reform this particular table. So I'll erase this table now. I'll create a new table again.
So in new table, P1, P2 will be one cluster, no? Then P2,
No, in the
P4,
new
P5.
cluster,
Yes.
I'll tell you how it will be. So in the new cluster now, I will have a new table that I'm going to construct, and the table will have values like it will have P1, the point remains the same. It will have P2, even this point remains the same. What is the new cluster that we have formed? P3, P6. So I'll have a new cluster point there. I'll have the P4 point. I'll have P5. And again, I'll have P1, P2, P3, P6, P4, and P5. Because I've already formed one cluster. So I have the data with respect to that. Now what I'll do, I have to again calculate from P1 to P1 it is 0. All these values will become 0. Okay. And then, I've already calculated these 4 values. That is from P3 to P6 to P1, it is 0.021. So I already know this value. And I already know from P2, yeah, it is 0.143. Okay. And I already know with respect to P4, it is 0.15. And with P5, it is 0.28. So I've already calculated this value. So I already know the distances of this value. Okay, so this is known to me. Now I have to calculate from P1 to P2. I already know the previous table, right? I already have the other values for the distances from my previous table. What is that? From P2 to P1, it is 0.23. From P4 to P1, it is 0.37. 0.20. I'll take the same value from my previous table. I have all these values. Okay, it's 0.34 and 0.14, 0.28 or 29. Yes, you got this clear now? You got this clear?
Yes, ma'am.
How did we get? Because we got the distances from all of these things. So this basically I've got it. How did I get this? I already calculated the distance of that cluster with the other points. I got this. The remaining values already I've calculated from the previous table. I'll take those values and place it. In this, okay, in this, which is the smallest distance now again?
P3, P6, P2 or P3, P6, P5 also. So P2.
How about this?
Yes.
0.14.
P5, P2.
Right? So 0.14 is lesser, still lesser. So what I'll take here is this point will next become my additional, because the distance between that is lesser between P5 and P2. So I'll have 2 and 5 will again become one more cluster. So I'm constructing my dendrogram simultaneously. 3 and 6, 2 and 5 now. Okay. So now again I'll be calculating the distances from P2 to P5. With this cluster, is there any other new data point close by? So again, I will start calculating the distance from here. So from P2 to P5 with respect to P1, I want the data. Again from P2 to P5 with respect to, what is the next term there? I can't take P2 because P2 is already there. So I cannot take P2. But after that it is P3 and P6. From the table it is P3 and P6. So it will become P3, P6. You got why P3 and P6? Because from each and every data point we are going ahead. So I first calculated with respect to P1. Now I have to calculate with P2, but already P2 is there. I cannot take P2 again. So the next data point will be P3 and P6. So P3 and P6 I will consider here. And after that, I have P4. So P2 and P5 with respect to P4. Okay. Then is there any other point? Already P5 is
That's it.
here. So I cannot use P5 also. I have to identify these three minimum distances. Can you tell me what is the minimum distances of these three? From P2 to P5 with respect to P1. So
0.2. 0.23.
Yes.
First, P2, P5, P1.
0.23. Exactly. The answer is correct. From P2 to P5 with respect to P3 comma P6, what will be the distance? Okay, maybe you might find this difficult. I'll just tell you. It's actually easy when you split it up. I'll just give you the split up for you to understand. Oh, there's only one more minute. There's only one more minute, guys. But meanwhile, let's see if we can go ahead. So I'll be writing from P2 with respect to P3 comma P6, because P3 and P6 we have already clustered. So I'll be taking this value comma P5 with P3 comma P6. So from P2 to P3 comma P6 is basically 0.143. So I'll get that 0.143 comma from P5